December 7th, 1941, 7:55 a.m., Pearl Harbor. As Japanese bombs fell on Battleship Row, the United States Army possessed exactly 123,000 M1 Garand rifles for an army that would soon swell to 8 million men. The mathematics of impossibility were clear. At the current production rate of 12 rifles per day at Springfield Armory, America would need 47 years to arm its expanding forces. The war would be lost before the 1st Division was properly equipped. Preparing and narrating this type of story took us long efforts and hard work. So, if you are enjoying the story, please consider subscribing to our channel. Yet by June 1944, American factories were producing one M1 Garand every 30 seconds. Not simplified versions, not rushed emergency models, but complete battle-ready rifles with 62 individual parts machined to tolerances of 1/10,000th of an inch. This transformation didn't emerge from military planning or industrial giants. It came from John Cantius Garand himself, a Canadian-born civilian employee at Springfield Armory who spoke English with a thick French accent and had never served a day in uniform. The revolution began not in 1941, but in 1936, when the U.S. Army officially adopted Garand's semi-automatic rifle after 17 years of development. Traditional arms manufacturers had dismissed the design as unnecessarily complex. The M1 contained twice as many parts as the bolt-action Springfield 1903 it was meant to replace. Each component required precision machining that seemed incompatible with mass production. Winchester Repeating Arms Company, with 70 years of firearms manufacturing experience, examined the M1 specifications in 1937. Their assessment was devastating. The gas cylinder alone required 14 separate machining operations. The operating rod, a critical component that converted gas pressure into mechanical action, needed tolerances that their best machinists could barely achieve working slowly and carefully. Winchester's chief engineer, Edwin Pugsley, wrote in an internal memo that the Garand rifle represented admirable engineering but impossible manufacturing. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The operating rod exemplified the manufacturing nightmare. This single part, resembling a bent metal arm about 14 inches long, required 47 distinct machining steps. It had to be forged from special chrome vanadium steel, heat-treated to exact specifications, bent to precise angles, while maintaining perfect straightness along its length, and finished to tolerances that traditional gunsmiths measured in thousandths of inches, where the M1 demanded 10,000ths. A variation of 2,000ths of an inch would cause the rifle to jam. Springfield Armory's master machinists, men who'd spent decades perfecting their craft, needed 4 hours to produce a single operating rod. The receiver, the rifle's central frame holding all other components, took 6 hours of concentrated work. At that pace, one skilled worker could produce components for perhaps one complete rifle per week. The Army needed millions. John Garand understood this crisis better than anyone because he'd created it. His rifle design prioritized battlefield performance over manufacturing simplicity. The semi-automatic action that gave American soldiers devastating firepower required complex mechanical relationships between components. But Garand possessed a unique perspective. Unlike traditional gun designers who came from shooting backgrounds, Garand had started as a mill worker, then became a tool designer, understanding machinery from the inside out. In January 1940, with war clearly approaching, Garand made a radical proposal to Colonel Guy Drury, Springfield Armory's commanding officer. Instead of simplifying the rifle, which would compromise its performance, they should revolutionize how it was built, not by making parts differently, but by creating machines that would make the parts automatically. Garand envisioned specialized devices that would perform all 47 operations on an operating rod without human intervention beyond loading raw material and removing finished components. Colonel Drury, a career artillery officer, found the proposal absurd. Firearms had always required skilled craftsmen. The idea that machines could replace master gunsmiths seemed like fantasy. But Garand had already begun designing these impossible machines in his off hours, working in a converted stable behind the armory, where he'd built his own workshop. The first breakthrough came with Garand's barrel drilling machine. Rifle barrels traditionally required deep hole drilling, one of the most challenging machining operations. A drill bit had to bore a perfectly straight hole through 34 inches of solid steel, maintaining concentricity within 0.02 of an inch. Skilled operators needed 2 hours per barrel, constantly withdrawing the bit to clear chips and realign the cut. Garand's machine used a revolutionary approach. Instead of pushing the drill through stationary steel, his design rotated the barrel blank at high speed while gradually feeding it onto a stationary drill. Pressurized oil flowed through hollow drill bits, continuously flushing chips and cooling the cut. The machine maintained alignment automatically through precision bearings and could complete a barrel in 11 minutes. No human judgment required, just load the blank and press start. Traditional manufacturers were horrified. Eliphalet Remington's descendants, running Remington Arms, declared Garand's approach heretical. Firearms were precision instruments requiring human skill and judgment. Machines couldn't read the subtle variations in steel hardness, couldn't feel when a cutting tool was dulling, couldn't make the microscopic adjustments that separated a fine rifle from scrap metal. But Garand understood something the traditionalists missed. Humans excelled at complex judgment but struggled with perfect repetition. Machines couldn't think but could repeat identical motions endlessly without fatigue or variation. If you could design a machine to perform an operation correctly once, it would perform it correctly 10,000 times. The receiver manufacturing process revealed Garand's genius most clearly. This complex frame required 128 separate cuts, drilled holes, and milled surfaces. Traditional production used universal milling machines operated by master machinists who interpreted blueprints and manually controlled cutting operations. Each receiver was essentially handcrafted, taking those 6 hours of skilled labor. Garand designed what he called a receiver duplicating machine. The device looked like something from science fiction, bristling with 24 cutting heads arranged around a central turret. The receiver blank was clamped in the center, and the turret rotated through positions where each cutting head performed one specific operation. Drill a hole here, mill a slot there, cut threads at exactly this depth. The operator's only job was loading blanks and removing finished receivers. The machine completed all 128 operations in 22 minutes. The precision achieved by these specialized machines exceeded what human machinists could consistently produce. When Springfield Armory tested 50 receivers made by master craftsmen against 50 made by Garand's machine operated by a worker trained for just 3 days, the machine-made receivers showed 60% less variation in critical dimensions. They were not just faster to produce, but actually better. By March 1941, 9 months before, Pearl Harbor, Garand had designed and built 17 specialized machines at Springfield Armory. Each replaced multiple skilled workers while producing components of superior consistency. The operating rod machine completed all 47 operations in 8 minutes. The trigger housing processor performed 33 operations in 6 minutes. The gas cylinder machine managed those 14 operations that Winchester had declared impossible in 4 minutes flat. But designing machines was only half the revolution. Garand's second insight was equally profound. Traditional arms manufacturing followed a craft model where skilled workers completed entire components. One machinist would perform all operations on a receiver, maintaining responsibility for quality but requiring comprehensive skills. Garand proposed something different, breaking production into discrete steps that could be learned quickly. Instead of training machinists to build rifles, Garand would train rifle builders to run specific machines. A worker didn't need to understand metallurgy or read complex blueprints. They needed to know how to load this particular blank into this particular fixture, press these buttons in this sequence, and recognize when something looked wrong. Complex skill became simple repetition. The training programs Garand developed were revolutionary for their time. Traditional apprentice gunsmiths spent 4 years learning their trade. Garand's operators were productive in 4 weeks. He created visual aids showing correct and incorrect parts, allowing workers to inspect by comparison rather than measurement. Color-coded fixtures prevented incorrect assembly. Foolproof gauges gave simple pass or fail readings without requiring interpretation. Springfield Armory became a laboratory for this new manufacturing philosophy. By summer 1941, production had risen from 12 rifles daily to 50. The workforce hadn't expanded proportionally. Instead, productivity per worker had quadrupled as specialized machines and simplified processes replaced traditional craftsmanship. The Army took notice. Colonel Drury, the skeptic who'd dismissed Garand's initial proposals, became his strongest advocate. In August 1941, Drury brought General Charles Wesson, Chief of Army Ordnance, to observe Springfield's transformation. Wesson watched a 19-year-old woman with 3 weeks of training operate the receiver duplicating machine, producing components that master gunsmiths couldn't match for consistency. General Wesson's report to the War Department was unequivocal. Garand has revolutionized rifle production. His methods must be immediately transferred to commercial manufacturers. We need millions of rifles, and only his approach can deliver them. The challenge was that commercial gun makers didn't want Garand's revolution. Winchester, Remington, and Savage Arms had invested decades in traditional methods. Their workers were craftsmen, their identity built on skill and precision. Adopting Garand's methods meant admitting their entire approach was obsolete. The first clash came in September 1941, when Winchester received a contract to produce M1 Garands. The company's engineers visited Springfield Armory, examined Garand's machines, and returned to New Haven convinced they could improve on his designs using their traditional approaches. Winchester's president, John Olin, believed his experienced workforce could match Garand's production rates without abandoning craftsmanship. Winchester's attempt was a disaster. Using traditional methods and master gunsmiths, they managed to produce exactly 39 rifles in their first 3 months. Each rifle required 370 man-hours of labor. At Springfield, Garand's methods were producing rifles with 41 man-hours of labor. Winchester was taking 9 times longer to build inferior rifles. The turning point came in December 1941. Pearl Harbor transformed rifle production from an industrial challenge to a matter of national survival. The War Production Board, established days after the attack, gained authority to mandate manufacturing methods. Companies could adopt Garand's approach or lose their contracts. John Garand himself became a traveling prophet of mass production, visiting factories across America with a team of Springfield engineers. They brought blueprints for specialized machines, templates for factory floor layouts, and detailed process sheets breaking down every operation. More importantly, they brought proof that it worked. The transformation at Winchester was representative. In January 1942, Garand's team arrived to find a factory floor organized around individual craftsmen's benches. Master gunsmiths worked independently, each building complete rifles from boxes of components. By March, the factory floor had been completely reorganized. Specialized machines arranged in logical sequence created a production line. Raw steel entered at one end, finished rifles emerged at the other. Workers who'd spent decades perfecting hand-fitting skills now operated single-purpose machines. The master gunsmith who'd proudly assembled entire rifles now watched a gauge that measured barrel straightness to millionths of inches. The resistance was real and sometimes bitter. Skilled workers saw their craftsmanship devalued, their years of experience made irrelevant by machines operated by teenagers. Some quit rather than accept the new reality, but others recognized opportunity in Garand's revolution. Tom Morrow, a master gunsmith at Remington with 30 years' experience, initially fought the changes. In a letter to his brother preserved in the Remington Company archives, he wrote about his transformation. "I spent 3 decades learning to file and fit parts by hand. Now a girl fresh from high school runs a machine that does it better. At first, I was insulted. Then I realized I could teach 10 girls to run 10 machines, producing more rifles in a day than I could build in a year." I'm not a craftsman anymore. I'm a production supervisor, and we're winning the war one rifle at a time. By June 1942, 6 months after Pearl Harbor, the revolution was accelerating beyond even Garand's optimistic projections. Winchester's production had risen from those pitiful 39 rifles in 3 months to over 1,000 rifles per day. Remington, starting from zero experience with the M1, was producing 800 daily. Springfield Armory, the prototype facility, was completing 2,000 rifles every 24 hours. The numbers were staggering but still insufficient. The Army was expanding toward 8 million men. Marine Corps units in the Pacific desperately needed semi-automatic firepower to match Japanese fanaticism. Allied nations were requesting Lend-Lease shipments. America needed not thousands but millions of M1 Garands. The solution came from an unexpected source: the automotive industry. In March 1942, William Knudsen, former president of General Motors, now serving as director of war production, visited Springfield Armory. Knudsen understood mass production better than anyone in America. He'd worked with Henry Ford, perfecting the assembly line, then competed against him building Chevrolets. Watching Garand's specialized machines, Knudsen saw opportunity for even greater optimization. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Knudsen proposed applying Detroit's assembly line principles to rifle production, not just specialized machines, but synchronized production where every operation was timed to feed the next without pause or accumulation. He assigned a team of automotive production engineers to study Garand's methods and enhance them with techniques from car manufacturing. The fusion of Garand's specialized machines with Detroit's assembly line expertise created something unprecedented. International Harvester, a company that had never made firearms, converted a tractor factory in Evansville, Indiana to rifle production. Using Garand's machine designs and automotive flow principles, they achieved something extraordinary. By September 1943, International Harvester was producing M1 Garands, faster than companies with centuries of combined gun-making experience. Their secret was treating rifles like tractors, complex assemblies built from standardized components flowing through synchronized operations. Workers didn't need to understand firearms. They needed to understand their specific task in the sequence. The operating rod that had taken 4 hours for a master machinist to produce was now completed in 4 minutes and 30 seconds. The process was broken into 47 steps, but each step was performed by a different specialized machine arranged in sequence. A steel blank entered the line and moved through stations automatically. By the time it emerged, every cut, bend, and surface finish was complete. The operator at each station performed one task: ensure the machine was functioning correctly. The human element hadn't been eliminated but transformed. Instead of craftsmen shaping metal, workers became quality controllers, managing machines. Every 10th component was inspected using go divided by no-go gauges that required no interpretation. If the part fit through one gauge but not another, it passed. If not, the entire batch was quarantined for inspection. This inspection system, developed by Garand and refined by automotive engineers, was revolutionary for weapons manufacturing. Traditional gunsmiths relied on personal judgment and experience to evaluate parts. Garand's system used gauges designed to check specific dimensions critical to function. Workers with days of training could perform inspections that previously required years of experience. The psychological transformation was as profound as the mechanical one. Workers who'd never held a rifle were building weapons that would protect democracy. Women who'd been told precision manufacturing was beyond their capabilities were operating machines that held tolerances professional gunsmiths couldn't match. The democratization of manufacturing skill paralleled the democratic cause they served. Rosie the Riveter had a sister nobody talked about, Sally the Rifle Builder. By 1943, women comprised 38% of the workforce at Springfield Armory. At International Harvester's Evansville plant, 43% of rifle builders were female. These weren't auxiliary positions. Women operated the most precise machines, performed critical inspections, and supervised production lines. Mary Brokowski, a 21-year-old former telephone operator, became a production supervisor at Winchester after just 6 months. Her section, staffed entirely by women aged 18 to 25, consistently exceeded production quotas while maintaining quality standards that earned War Department commendations. In a letter to her husband, serving with the 1st Infantry Division in North Africa, she wrote about the pride of contribution. "Every rifle we complete is stamped with a serial number. I imagine that number in some soldier's hands, maybe saving his life. We're fighting the war here too, 30 seconds at a time." The 30-second cycle time became the holy grail of M1 production. Garand's original vision had been to produce rifles as efficiently as possible. The automotive engineers transformed this into a precise rhythm. Every operation in the factory was timed and synchronized to support a 30-second completion rate. This meant the barrel drilling machine had to complete a barrel every 30 seconds. The receiver duplicating machine had to finish a receiver every 30 seconds. The dozens of smaller components, triggers, sears, hammers, springs, all had to flow at the same rate. If any single operation took 31 seconds, the entire line would eventually stop. Achieving this synchronization required mathematical precision in production planning. Garand worked with industrial engineers to calculate the exact number of machines needed for each operation. If barrel production took 11 minutes on one machine, they needed 22 machines running continuously to achieve 30-second throughput. If receiver production took 22 minutes, they needed 44 machines. Preparing and narrating this type of story took us long efforts and hard work. So if you are enjoying the story, please consider subscribing to our channel. The investment was staggering. Each specialized machine cost between $15,000 and $40,000 in 1942 dollars. Springfield Armory alone installed over 300 specialized machines. Winchester added 450. International Harvester, starting from nothing, purchased over 600 machines. The total investment in specialized equipment exceeded $100 million, equivalent to over $1.5 billion in modern currency. But the payoff was proportional. By December 1943, 2 years after Pearl Harbor, American factories were producing 100,000 M1 Garands monthly. The impossible had become routine. Rifles that couldn't be built fast enough to equip a single division were now arming entire armies. The quality achieved through mechanized production exceeded traditional craftsmanship. In 1943, Army Ordnance conducted extensive testing, comparing hand-fitted rifles, built by master gunsmiths, with mass-produced rifles from Garand's mechanized lines. The mass-produced rifles showed superior consistency in accuracy, reliability, and parts interchangeability. Parts interchangeability became the ultimate proof of precision. Traditional hand-fitted rifles required individual adjustment. Parts from one rifle wouldn't necessarily work in another. Garand's mass-produced rifles achieved true interchangeability. Any part from any rifle would function perfectly in any other rifle. Soldiers could cannibalize damaged weapons for parts with complete confidence. This interchangeability saved countless lives in combat. During the Battle of Saipan in June 1944, Marines reported field-stripping damaged rifles under fire, combining functional components to create working weapons. The ability to maintain rifles using battlefield salvage was possible only because of the precision achieved through mechanized production. The strategic impact transformed American tactical doctrine. Pre-war Army manuals assumed infantry would be armed with bolt-action rifles, firing aimed shots at deliberate intervals. The M1's semi-automatic action, combined with its massive availability, enabled revolutionary tactics. American soldiers could provide suppressive fire while maneuvering, overwhelming German and Japanese positions with sustained, accurate fire. German intelligence reports from 1943 expressed shock at American small arms production. A captured Wehrmacht document from the Battle of Kasserine Pass noted that American infantry units possessed firepower equivalent to units twice their size due to universal semi-automatic armament. German soldiers, mostly armed with bolt-action Kar-98K rifles, were outgunned in every engagement. The Japanese faced similar disparities in the Pacific. Their Type 99 rifle, while excellent, was bolt-action and produced using traditional methods. Japanese arsenals managed to produce approximately 800,000 rifles annually at peak production. American factories were producing that many M1 Garands every 8 months, and the gap was widening. The production miracle wasn't limited to quantity. Continuous improvement, another concept borrowed from automotive manufacturing, meant rifles produced in 1944 were superior to those from 1942. Springfield Armory established a feedback system where combat reports were analyzed for improvement opportunities. Soldiers reported that operating rods occasionally bent under extreme field conditions. Within 3 months, Garand redesigned the heat treatment process, increasing strength by 15% without changing dimensions or weight. Triggers were reported as too heavy for accurate shooting under stress. The sear engagement angle was modified by half a degree, reducing trigger pull by 2 pounds while maintaining safety. These improvements were immediately incorporated into production across all facilities. Unlike traditional manufacturing, where changes required extensive retooling, Garand's specialized machines could be adjusted with cam changes or fixture modifications. An improvement developed at Springfield on Monday was being implemented at Winchester and International Harvester by Friday. The learning curve effect was dramatic. In January 1942, building an M1 Garand required 41 man-hours of labor. By January 1943, the time had dropped to 24 man-hours. By January 1944, it was down to 8 man-hours. By January 1945, American factories were completing rifles with just 4.5 man-hours of labor. Cost reduction paralleled efficiency gains. The first M1 Garands, produced in 1937, cost the government $312 each. By 1942, mass production had reduced the cost to $85. By 1944, the per-unit cost was $31, less than a tenth of the original price, while quality had actually improved. The economic multiplier effects rippled through American industry. Steel mills expanded capacity to meet rifle steel demands. Machine tool builders, producing Garand's specialized equipment, developed capabilities that would define American manufacturing supremacy for decades. The precision bearing industry, critical for machine accuracy, advanced 20 years in 3. Small component suppliers experienced similar transformations. The Union Hardware Company of Torrington, Connecticut, traditionally made door hinges and cabinet hardware. They received a contract to produce M1 trigger guards, a seemingly simple stamped steel component. Using Garand's philosophy of specialized equipment, they designed a progressive die that completed all forming operations in a single press stroke. Their production rate exceeded 10,000 trigger guards daily with just 12 workers. The Winchester Repeating Arms Company's transformation was particularly symbolic. The company that had declared Garand's rifle impossible to mass produce was now building them at rates that seemed impossible even to Garand. Their New Haven factory covered 40 acres of floor space, employed 11,000 workers, and operated 24 hours daily. The production flow was so refined that raw steel entering the factory emerged as a completed rifle in under 72 hours. By D-Day, June 6, 1944, American forces possessed overwhelming small arms superiority. Every infantry soldier carried an M1 Garand. Paratroopers jumping into Normandy had rifles that were mechanically identical, whether built in Massachusetts, Connecticut, or Indiana. The industrial symphony Garand had composed was playing at full volume. The human statistics were as impressive as the production numbers. Springfield Armory's workforce peaked at 13,500 workers. 62% had no prior manufacturing experience. 38% were women. 14% were African Americans working in integrated production lines, unusual for 1940s America. The average age was 23. These young, inexperienced workers were outproducing craftsmen with decades of experience. Training programs had evolved into models of efficiency. New workers received 3 days of classroom instruction using cutaway rifles and demonstration fixtures. They then spent 2 weeks on the production floor under supervision, operating one specific machine. By week 3, they were fully productive. By month 3, many were exceeding standard rates and training newer workers. The accident rate in rifle production was lower than traditional manufacturing despite the pace and pressure. Garands machines incorporated safety interlocks preventing operation unless guards were in place. The repetitive nature of specialized tasks meant workers developed muscle memory, reducing errors. The inspection systems caught problems before they cascaded into dangers. Quality control evolved into statistical process control. Another automotive innovation adapted to rifle production. Instead of inspecting every component, workers checked samples and plotted measurements on control charts. Trends were identified before they became problems. A cutting tool wearing gradually would be replaced before it produced out of specification parts. The metallurgical advances, driven by rifle production, had lasting impacts. The chrome vanadium steel, specified for operating rods, required precise alloy control, previously considered impossible in mass production. Steel companies developed spectrographic analysis techniques enabling real-time composition monitoring. These methods became standard in all precision steel production post-war. Heat treatment, critical for achieving proper hardness and durability, advanced from art to science. Traditional heat treaters relied on experience and visual cues. Garand specified exact temperatures, timing, and cooling rates. Furnaces were equipped with automatic controls, maintaining temperatures within 5 degrees. The same precision heat treatment used for rifle parts would later be applied to jet engine components and spacecraft. The summer of 1944 represented peak production efficiency. American factories were completing one M1 Garand every 30 seconds around the clock. That meant 120 rifles per hour, 2,880 per day, 20,160 per week, over 1 million per year from all facilities combined. Each rifle contained 62 parts. American factories were producing 62 million components annually, each machined to exacting specifications, heat-treated to precise hardness, finished to exact dimensions, and assembled into weapons that would function reliably from Arctic cold to jungle heat. The logistics of component flow resembled military operations themselves. Springfield Armory's production control room looked like a military command center. Massive boards tracked component production, assembly rates, inspection results, and shipping schedules. Controllers coordinated between departments, ensuring no bottlenecks developed. If trigger production fell behind, resources shifted immediately to restore balance. Transportation between operations was revolutionized. Traditional factories used workers to carry components between stations. Garand implemented conveyor systems, overhead trolleys, and automated transfer mechanisms. Components moved continuously through production without human handling. This reduced damage, improved tracking, and freed workers for value-adding operations. The precision achieved in mass production exceeded anything previously imagined. When Army ordnance tested interchangeability in 1944, they disassembled 100 rifles from different manufacturers, mixed all components randomly, and reassembled them. All 100 rifles functioned perfectly. No hand fitting, no adjustment, just complete mechanical interchangeability. This level of precision had profound implications for military logistics. Spare parts could be stockpiled without concern for matching serial numbers. Battle-damaged rifles could be repaired using components from any source. The nightmare of maintaining weapons in combat was transformed into routine procedure. Field maintenance itself was revolutionized by production precision. The M1 Garand could be field stripped without tools in under 60 seconds. Every soldier learned this procedure in basic training. The precision of mass-produced parts meant reassembly was foolproof. Components could only fit together correctly. This designed-in simplicity was possible only because manufacturing held such tight tolerances. The psychological impact on American soldiers was immeasurable. They carried rifles superior to any enemy weapon, maintained easily under combat conditions, with unlimited spare parts available. The confidence this provided translated into aggressive tactics and battlefield dominance. German prisoners of war, interviewed after capture, consistently mentioned American firepower superiority. A Wehrmacht sergeant captured in the Hürtgen forest stated that his squad's bolt-action rifles couldn't match the sustained fire from American M1s. We fired 1 shot, they fired 8. We were always outnumbered, even when we weren't. Japanese accounts from island battles in the Pacific echoed similar themes. The official history of the Japanese 31st Army, defending Saipan, noted that American small arms fire was so intense that Japanese troops couldn't raise their heads from cover to aim properly. The volume of fire from semi-automatic rifles created a fundamentally different battlefield dynamic. The production achievement extended beyond mere numbers to represent a philosophical victory. Totalitarian nations had militarized their entire societies for war production. Democratic America had transformed civilian factories using civilian workers to outproduce militarized economies. The rifle built every 30 seconds was proof that free societies could mobilize more effectively than regimented ones. International observers were stunned by American production achievements. Soviet representatives, visiting American factories through Lend-Lease agreements, reported back to Moscow about production methods that seemed impossible. British ordnance officers studying American techniques acknowledged that centuries of gun-making tradition had been rendered obsolete in less than 3 years. The French, whose own arms industry had been destroyed, sent engineers to study American methods for post-war reconstruction. They found not just superior machinery, but a completely different conception of manufacturing. The idea that complex precision products could be built by minimally trained workers using specialized equipment challenged fundamental assumptions about industrial organization. Even within America, the transformation was difficult to comprehend. Senators visiting rifle factories for oversight couldn't reconcile the young workers they saw with the precision weapons being produced. One senator, watching an 18-year-old woman operate a receiver duplicating machine, asked how long she'd trained. When told 3 weeks, he accused the factory manager of deception. Only after watching her work and inspecting the components did he accept the reality. The peak production moment came on August 14, 1944. Winchester's swing shift completed their 10,000th rifle of the day, setting a single factory record. The serial number, 3,500,000, marked another milestone, EAA, the 3.5 millionth M1 Garand produced since Pearl Harbor. In 32 months, America had manufactured more semi-automatic rifles than all other nations combined had produced of all rifle types. John Garand was present for the ceremony. The quiet engineer who'd revolutionized manufacturing typically avoided publicity. But this moment validated 20 years of work, from his first semi-automatic designs in 1924 to the production miracle of 1944. He held the ceremonial rifle briefly, then handed it to Mary Brokowski, the production supervisor whose section had assembled it. In his brief remarks, recorded by factory newsreel cameras, Garand captured the democratic essence of the achievement. This rifle was not built by me or any individual. It was built by thousands of Americans who learned that ordinary people can do extraordinary things when given proper tools and clear purpose. Every rifle we produce carries not my name but America's promise, that free people, working together, can overcome any challenge. The promise was being fulfilled on battlefields worldwide. From the hedgerows of Normandy to the islands of the Pacific, American soldiers carried identical rifles, built to identical standards by workers who'd never met, but shared identical training. The industrial democracy Garand had envisioned was arming political democracy's defense. As 1944 turned to 1945, production remained at peak efficiency even as victory approached. The The planned invasion of Japan was expected to require millions of rifles for the expanded forces needed. Production schedules called for continued maximum output through 1946. The atomic bombs that fell on Hiroshima and Nagasaki in August 1945 rendered millions of M1 Garands suddenly unnecessary. On August 14, 1945, the same date Winchester had set their production record exactly 1 year earlier, President Truman announced Japan's surrender. Within hours, telephone calls from the War Department reached every rifle factory. Cease production immediately. The shutdown was as dramatic as the build-up had been. At Springfield Armory, the swing shift was midway through their 8-hour stint when the announcement came over the public address system. Workers who'd been operating at maximum pace for nearly 4 years simply stopped. Partially completed rifles remained in fixtures, operating rods frozen mid-stroke in their specialized machines. The sudden silence after years of 24-hour operation was deafening. Mary Brokowski, now production floor manager for Winchester's entire Building 5, described the moment in her diary. "We'd been running so long at full speed that nobody knew how to stop. Some women cried, others cheered. I walked the line looking at all those incomplete rifles and realized each one represented a life that wouldn't be lost invading Japan. The best rifles are the ones that never need firing." But the production miracle's end was also a beginning. 4 million M1 Garands had been produced between December 1941 and August 1945. The manufacturing revolution Garand had initiated would transform American industry permanently. The specialized machines, the production techniques, the quality control methods, and most importantly, the philosophy that complex products could be built by ordinary people using extraordinary processes, would define American manufacturing supremacy for the next half-century. John Garand himself faced an unexpected challenge. Despite revolutionizing rifle production and arguably contributing more to Allied victory than any other civilian, he'd never patented his design. As a government employee at Springfield Armory, his inventions belonged to the United States. While private contractors made millions from his innovations, Garand continued drawing his modest civil service salary. Congress attempted to rectify this injustice. In 1945, a bill was introduced granting Garand $100,000 in recognition of his contributions. The amount was less than a penny per rifle produced, a fraction of what patents would have earned. Yet even this modest recognition faced opposition. Some congressmen argued that rewarding government employees for doing their jobs set dangerous precedents. The bill died in committee. The workforce that had achieved the impossible faced their own transitions. Women who'd proven themselves capable of precision manufacturing were encouraged to return to domestic life. Many resisted. They'd tasted independence, earned real wages, and contributed to world-changing events. The skills they'd developed operating sophisticated machinery didn't disappear with peace. Sarah Chen, a 22-year-old Chinese-American who'd operated receiver-duplicating machines at International Harvester, used her experience to establish one of the first woman-owned precision machining companies in California. Her firm, started with 3 surplus rifle-making machines bought at government auction, would eventually produce components for the aerospace industry. "The M1 taught us that precision wasn't masculine or feminine," she later testified before Congress. "It was either correct or incorrect. The machines didn't care who operated them." African-American workers who'd been integrated into rifle production lines faced returning to segregated workplaces. James Washington, who'd supervised barrel production at Springfield Armory, found himself offered only janitorial positions at civilian factories despite his expertise. He eventually established his own gunsmithing business, specializing in accurizing M1 Garands for competitive shooting. His modifications, based on intimate knowledge of production variations, made him legendary among competition shooters. The international impact of Garand's production methods rippled globally. Soviet engineers, who'd observed American production through Lend-Lease programs, attempted to replicate the specialized machine approach for AK-47 production. They succeeded partially, but never achieved the precision or interchangeability of American methods. Soviet rifles required hand-fitting well into the 1970s. The British, rebuilding their destroyed industrial base, explicitly adopted Garand's principles. The Royal Small Arms Factory at Enfield was redesigned using American-style, specialized machines and production flows. British engineers studying at Springfield Armory brought back more than technical knowledge. They absorbed the democratic manufacturing philosophy, where workers were partners in production, not merely pairs of hands. Japan's post-war industrial miracle owed debts to Garand's revolution. Japanese engineers, permitted to study American production methods during occupation, were astounded by the systematic approach to quality and efficiency. The concepts of specialized equipment, statistical process control, and continuous improvement that Garand had pioneered became foundational to Japanese manufacturing philosophy. Toyota's production system, which would later reconquer American markets, traced lineage directly to rifle production lines. The machines themselves found second lives. Thousands of specialized devices, designed for single operations on rifle components, were sold as military surplus. Clever entrepreneurs discovered that machines designed to hold 10,000th-inch tolerances on rifle parts could produce civilian products with unprecedented precision. The Waterbury Clock Company bought dozens of trigger assembly machines, converting them to produce watch movements. The precise fixtures and cutting patterns that had shaped rifle triggers now created delicate timepiece components. American watches, previously inferior to Swiss craftsmanship, suddenly competed globally. The aerospace industry, exploding in the 1950s, desperately needed precision manufacturing capability. They found it in surplus rifle production equipment and, more importantly, in workers trained on that equipment. Boeing hired over 3,000 former rifle production workers for their Seattle facilities. These workers understood tolerances, process control, and the discipline required for life-critical components. The human legacy was equally profound. 4 years of rifle production had trained hundreds of thousands of Americans in precision manufacturing. This workforce didn't disappear with war's end. They became the foundation of American industrial expansion. Cities that had hosted rifle production became manufacturing centers. Springfield, Massachusetts, New Haven, Connecticut, Evansville, Indiana. Each retained sophisticated manufacturing capabilities and trained workers. Community colleges, recognizing the value of production training, established programs based on Garand's methods. The Springfield Technical Community College, founded in 1946, used surplus rifle machines to teach manufacturing principles. Their graduates, trained on equipment that had armed democracy, would build everything from jet engines to computer components. Garand himself continued innovating until retirement in 1953. His post-war projects included production methods for the M14 rifle and early experiments in numerical control, precursor to computer-controlled manufacturing. He received numerous honors, including the Medal for Merit and the Civilian Medal of Honor, but the recognition he valued most came from soldiers. At a 1951 reunion of 1st Infantry Division veterans, Garand was invited as honored guest. Hundreds of combat veterans lined up to shake his hand. One sergeant, who'd fought from North Africa through Sicily to Normandy, spoke for many. "Mr. Garand, I carried serial number 1,847,293 for 2 years. That rifle never failed me, not once. You didn't just build weapons, you built trust." The economic impact of rifle production extended decades beyond war's end. The machine tool industry, expanded to produce Garand's specialized equipment, found new markets in consumer goods. Companies that had built rifle machines now created devices for washing machines, refrigerators, and automobiles. The precision bearing industry, refined for rifle production, enabled everything from hard drives to satellites. Statistical process control, developed to monitor rifle quality, became standard in all manufacturing. The control charts that tracked barrel straightness now monitored pharmaceutical purity and semiconductor yields. The go divided by no-go gauges that checked trigger dimensions inspired quality systems across industries. The philosophical transformation was perhaps most lasting. Pre-war American manufacturing had been dominated by craft traditions inherited from Europe. Master craftsmen, lengthy apprenticeships, and hand-fitting were considered essential for quality products. Garand had proven this false. Quality came from well-designed processes, not individual skill. This democratization of manufacturing capability would define American production philosophy through the 20th century. Critics argued that Garand's methods had destroyed craftsmanship, reducing skilled work to mindless repetition. They pointed to the bitter resistance of traditional gunsmiths as evidence that something valuable was lost. But supporters countered that democratizing production capability had enabled millions to participate in manufacturing who would have been excluded by traditional apprenticeship systems. The debate continues today in discussions about automation and artificial intelligence. When machines can perform tasks better than humans, what role remains for human skill? Garand's revolution suggested an answer. Humans design systems, machines execute them, and humans monitor and improve the results. The partnership between human creativity and mechanical precision, first proven in rifle production, remains the model. By the Korean War, 1950 to 1953, the M1 Garand proved its continued relevance. Rifles produced during the World War II production miracle functioned perfectly after years of storage. The interchangeability Garand had achieved meant that rifles built in different factories in different years could share parts seamlessly. Marines at Chosin Reservoir combined parts from damaged rifles to create functional weapons in sub-zero temperatures where precision hand-fitting would have been impossible. The Vietnam War saw the M1 Garand's gradual replacement by the M14 and later the M16, but the production principles Garand established built these new weapons. The M16, despite its troubled introduction, was manufactured using specialized machines and flow production directly descended from Garand's innovations. When production needed to accelerate for Vietnam escalation, factories applied lessons learned 20 years earlier. International conflicts continued, proving Garand's design wisdom. Israeli forces in 1967, still equipped with some M1 Garands, found them superior to newer weapons in desert conditions. The rifle's simplicity and the precision of its mass production meant it functioned reliably where more complex weapons failed. Greek forces successfully used M1 Garands against Turkish invaders in Cyprus in 1974, the rifles performing perfectly 30 years after manufacture. The collector market that emerged for M1 Garands revealed the lasting quality of mass production. Rifles discovered in attics and basements, untouched for decades, often functioned perfectly after basic cleaning. The precision of manufacture and quality of materials meant that time hadn't degraded their capability. Collectors found that rifles from different manufacturers, different years, even different production runs, maintained consistent quality. This consistency had been Garand's greatest achievement, not the speed of production, though that saved democracy, not the cost reduction, though that enabled massive armament, but the proof that mass production could achieve quality equal to or exceeding handcraftsmanship. Every rifle, whether serial number 100 or 4 million, met the same exacting standards. The civilian marksmanship program, distributing surplus M1 Garands to American citizens, has revealed the production miracle's lasting impact. Rifles, manufactured in the 1943 production surge chute as accurately as those carefully assembled in 1941. The democratic ideal that every soldier deserved the best weapon applied equally. Every rifle was built to the same standard regardless of who would carry it. Modern manufacturing engineers study Garand's methods as historical foundation for contemporary production. The concepts seem obvious now. Specialized equipment, statistical process control, designed-in quality, continuous improvement. But in 1940, these were revolutionary. Garand didn't just solve a production problem, he invented modern manufacturing philosophy. The Industry 4 revolution, with its smart factories and Internet of Things sensors, builds on Garand's foundation. Where he used mechanical cams to control cutting sequences, modern factories use computer numerical control. Where he employed workers to monitor gauges, artificial intelligence now detects variations. But the principle remains: design processes that produce quality automatically, then monitor and improve continuously. Environmental historians note an overlooked aspect of Garand's revolution. Traditional craft production generated enormous waste through mistakes and rework. Hand fitting required removing material until parts matched, generating scrap. Garand's precision production minimized waste. Parts were made correctly initially, eliminating rework. This efficiency, multiplied across millions of rifles, saved enormous quantities of strategic materials during wartime shortage. The social impact extended beyond manufacturing. The M1 Garand production miracle demonstrated that ordinary Americans could accomplish extraordinary feats through systematic organization. This confidence influenced post-war society. If factory workers could build precision rifles, what couldn't Americans achieve? The GI Bill, the Interstate Highway System, the space program, TAS, all reflected confidence born from wartime, production achievements. Educational institutions recognized implications for technical training. MIT established its Leaders for Manufacturing program, explicitly incorporating lessons from rifle production. Stanford's Industrial Engineering Department analyzed Garand's methods as case studies in system optimization. Business schools taught the transformation of Winchester and International Harvester as examples of organizational change. The gender implications resonated through women's liberation movements. Rosie the Riveter became an icon, but the women who built M1 Garands provided concrete proof of capability. They hadn't just supported war effort, they'd performed precision manufacturing equal to any craftsman. When 1960s feminists argued for workplace equality, they could point to 1940s production records as undeniable evidence. Racial integration lessons from rifle production influenced civil rights movements. The integrated production lines at Springfield Armory had proven that racial cooperation was not just morally right but economically superior. Production records showed that integrated shifts outperformed segregated ones. When executives argued integration would reduce efficiency, advocates could cite rifle production statistics proving otherwise. International development programs applied Garand's methods globally. The Point 4 program, providing technical assistance to developing nations, explicitly taught specialized equipment and flow production techniques pioneered for rifles. Nations lacking skilled craftsmen could nonetheless establish precision manufacturing using Garand's approach. South Korea, Taiwan, and Singapore built industrial economies on these principles. The story comes full circle with modern defense production. The war on terror created urgent needs for up-armored vehicles, precision weapons, and sophisticated equipment. Manufacturers applied lessons from M1 Garand production. Specialize equipment, simplify the operations, monitor quality statistically, improve continuously. The MRAP vehicles protecting soldiers from IEDs were produced using methods John Garand would recognize. Even today, 75 years after the production peak, M1 Garands remain in service. Ceremonial units carry them for their reliability and historical significance. Some Allied nations maintain them as reserve weapons. Competitive shooters treasure them for their accuracy. Each functioning rifle testifies to the permanence of precision mass production. John Cantius Garand died on February 16, 1974, aged 86. His obituary in the New York Times called him the man who armed American democracy. But his legacy transcends weapons. He proved that free societies could mobilize production more effectively than authoritarian ones, that ordinary workers could achieve extraordinary precision, that quality and quantity weren't opposing goals but complementary achievements. The Springfield Armory, where Garand performed his revolution, is now a national historic site. Visitors can see the specialized machines, now silent, that once produced democracy's arsenal. The guest book contains entries from around the world. A recent entry from a Japanese engineer reads, "Here began modern manufacturing, not just rifles, but a new way of thinking about how things are made and who can make them." The M1 Garand production miracle wasn't just about building rifles quickly. though 4 million in 44 months remains astounding. It was about transforming American manufacturing philosophy, democratizing precision production, and proving that systematic innovation could overcome any challenge. Every product manufactured today using specialized equipment, statistical quality control, and continuous improvement carries DNA from John Garand's revolution. The 30-second rifle that seemed impossible in 1941 became routine by 1944, but more than rifles rolled off, those production lines. American industrial confidence, social transformation, and economic supremacy were manufactured alongside each M1 Garand. The rifle that armed democracy also transformed it, creating the manufacturing capability that would define American prosperity for generations. The story ends where it began, with mathematics. 8 million soldiers needing rifles, 44 months to build them, 4 million rifles produced, 30 seconds per rifle at peak production. But the most important number may be one immigrant engineer who revolutionized how humanity manufactures precision products. John Garand didn't just arm democracy for World War II, he equipped civilization for the modern age. The production lines are silent now, the workers dispersed to history, the urgent need long past. But in every modern factory, in every quality control chart, in every specialized machine performing precise operations, the ghost of the M1 Garand production miracle persists. Democracy's arsenal became democracy's industrial foundation, one rifle, one innovation, one transformed life at a time. Preparing and narrating this type of story took us long efforts and hard work, so if you are enjoying the story, please consider subscribing to our channel